Welcome everyone to my channel. My name is Mon, Sir Mon.
Okay, so let me share now my slides. Okay, I titled it Research in Action Beyond Expectations, coming from the very nice start of Dr. Sandra. And I would just name it the Statistics in Research. Okay, shall I proceed now, sir? Hello? Hello, sir?
Hello? Yes, sir.
Shall I proceed now with my presentation? Okay. So again, let me greet everyone a good evening and Shubo Shonda. And let me greet our regional math supervisor, Dr. Nestor Nuesca, our school division superintendent, Dr. Irene P. Tamayo from Angeles City, our district supervisor, Madam Esperanza Malang, our school principal, Madam Casarina L. David, and our senior high school head and school assistant principal, Madam Lutgarda C. De Jesus. And of course, my fellow teachers and our students who are joining us this evening. Okay, but first, let me ask from our audience right now, how many of you are statisticians? How many of you are researchers? How many are teachers? How many are already experts in the fields of statistics? May I see the chat in our chat box? Hello, so that I would know how I'm going to start my my talk on the statistics in research. Okay, I'm still waiting for some of the some of the replies. So let me just move my there should be some delay in broadcast. So I just want to make sure that I'm talking to to the proper audience. As I've said, even in my other or previous talks, we may not be able to cover everything about statistics in 1 hour. Okay, and so I will just focus on some relevant items or lessons that we may learn from in order to apply this special field of mathematics, which is statistics, especially in research. Okay, so again, I'm asking how many are statisticians in the audience right now. How many are researchers? How many are teachers? Can you just give me some glimpse of our audience right now? If I may ask you, or how many are expert already? Okay. I'm still looking at the last few messages from Dr. Sandra. Okay. Let me see. So, how many are teachers, if I may ask? Teachers, okay. Can you tell me if you're a teacher or a statistician or an expert in stat or a newbie? Okay. Good evening, everyone. Good evening. Many are sending their good evening messages. I'm a trainer and a mentor from Anwar Uzman Asad. That's good. I am a teacher from Mary Joy Cañete. Okay, a teacher and a researcher. Very good. And I still have to see somebody who would say I'm a statistician. And so I'm a math major. Okay, that's great. A bit knowledgeable in statistics. Instructor. Okay, someone is a statistician. my fellow statistician, Antonio Bronia. Okay, accountancy. Okay, great. So more or less, I have an idea. So again, as I've said, we may not be able to cover everything about statistics in 1 hour. So I'll probably tackle some of the major things that would help you in the field of research. Okay, so to start it, we know what is going on right now in our world today. And COVID has given the world a new definition of normal. And that's why we now call it the new normal, right? Without anything else, we need to survive. And that's the number one thing. Okay. And with that, research has never been as widely heard than decades before. Of course, everybody is doing research on the new vaccines. Okay. You can see it from the news every day. Research are being done. What has to be done in order to stop or, stem this pandemic. Statistical information has cast a great cloud in all places around the globe, featuring cases of COVID, recoveries, and sadly, deaths. In today's world, data is needed in almost all areas of our life, our existence, from national security, economy, to individual physical state of health. And from one participant I saw a while ago, from Miss Lynn Caro, she posted in the chat box, and I quote, "True research should accurately measure what it intends to measure." Very good, right? End of quote. But how do we process this humongous information, the big data, so to speak? Why do a statistical research? Or why do statistical tests? To verify the trends. Okay, so let's see. The field of statistics exists because it is usually impossible to collect data from all individuals of interest. Population, which is so huge. Our only solution is to collect data from a subset, sample, as we say, of the individuals of interest. But our real desire is to know the truth, just like Ms. Carol said, about the population. Quantities such as means, standard deviations, and proportions are all important values and are called parameters when we are talking about population. Okay? We can, however, calculate estimates of these quantities for our samples when they are calculated from sample data. These quantities are called statistics in many books. And a statistic estimates a parameter. Okay? Since we usually cannot get data from the whole population, we cannot know the real values because it's moving. Okay? We rely on our information or statistics from our sample set of data. I hope it's getting clearer. So that's just to introduce to you the field of statistics. There are mainly two types of variables, the discrete and continuous, which we all studied in our basic statistics class. Okay? But for purposes of testing our variables, we can group them into dichotomous, categorical, or data scales. Okay? And statistical tests can be categorized as well into parametric and non-parametric. And to simplify these categories, parametric tests assume the distribution of the parameters. We will assume, like, we know the several types of distribution. We know the normal, binomial, Poisson, all these things that we studied in the past. And mostly parametric tests assume normality when it comes to, doing testing of our research, I'll just focus on our research, like mean, standard deviations, proportions, and even the differences or residuals. The non-parametric tests do not assume. Well, that's a good thing. We still have something to deal with in case our parameters or our assumptions did not comply. Okay, so we have the non-parametric tests, which do not assume any distribution. It's distribution-free, and therefore do not need to satisfy the normality of the distribution, the requirement for normality. Now, parametric statistical procedures rely on assumptions about the shape of the distribution. Let's assume it is a normal distribution, okay? And in the underlying population about the form or parameters, meaning to say the means, the standard deviation, proportion, etc. of the assumed distribution. And non-parametric statistical procedures rely on no or few assumptions about the shape, okay, of the parameters, okay, or the population or the distribution itself, okay? Now, choosing the right statistical test. If you look at your SPSS, of your Excel, there are so many applications nowadays which you can download. It talks about several statistical tests. Well, don't let the weird names scare you at all. It's all just typical statistician mumbo jumbo, but the tests themselves are powerful, mind you. Valuable devices to help you in your scientific research. And a computer can do all the tricks, the gnarly mathematical computations, for you. So don't be scared. All you have to do is pick the right test for your particular experiment or research or field of study. And the statistical test that you select will depend upon your experimental design, especially the sorts of groupings, controlled and experimental, the variables, we call them independent and dependent or response, and treatment levels, okay, that you are working with, okay? So now, keep in mind that a statistical test is always a test on your null hypothesis. We have a hypothesis, something that we assume, okay? And that's the basic, the null hypothesis. More specifically, it tests the probability that your null hypothesis is valid. More to the point, it tests the probability that the two or more estimated means, maybe from your study and expressed in your null hypothesis, belong to the same distribution of means, or whether they probably belong to two or more different distributions. And in choosing the right statistical test, there is a popular assumption when it comes to choosing the proper statistical test, and that is the popular normal distribution. As an illustration to what I said, here are the graphs of the distribution of the number of heads when tossing 5 coins, 10 coins, 20 coins, or 30 coins. Or what I'm saying is if you're increasing the number of coins, or you can also toss one coin repeatedly, like 5 times, 10 times, 20 times, and 30 times. So take a look at this. Okay. Here you have 5 coins, and this is the graph of the distribution. For 10 coins, you notice that it became a little smoother, right? For 20 coins, it became much more smooth. And for 30 coins, it already resembles that of a normal distribution. Okay, isn't that amazing? So as you increase, as I've said, the law of large numbers will help you get through it. Okay, and the standard normal came into the picture. We're not talking about the standard normal. A while ago, I'm talking about just the normal distribution. Okay, it came into the picture to standardize all units of variables into one single Z distribution. Why? Because that means studies on weights, heights, volumes, scores, grades, etc., no? Which are in different units like inches, meters, pounds, kilograms, cubic meters, cubic centimeters, you can now utilize only one single table of values called the standard normal table, okay? To convert the original unit to a standard unit of Z using a formula Z is equal to X minus mu over sigma. We will not deal with that formula much more. So you are ready to get your samples, right? Okay, so how do we get the samples now? Now that you know what a normal distribution is all about, let me first introduce the concept of the parameter and statistic. So from the big data to small data, no? So we apply the proper sampling technique or methodology in order to get a statistic closest to the population parameters. Meaning to say we are targeting the population parameters. And how do we get those values? By using sample Okay, statistic. Okay, a parameter is a number that describes the population. It describes the population. So it is a fixed number, but in practice, we may not know its true value. Well, because, like for example, if you get the averages of all Asians, okay, when somebody dies while you're doing the research, it will change already. When somebody is born, it will change already. So it's a moving value, right? But we can always estimate it, right? So we're talking of parameter. We're talking of population mean, population variance, population standard deviation, and population proportion, etc. Everything about the population. And we call it the parameter. Okay? And let me add some more. Example could include the following. Okay, let me see. A census was taken and the average number of children of a family in the whole island, okay, is 8. The number of children is 8. So meaning to say, for the whole place, meaning to say he was able to do a census and the average number of children is 8. Now, another thing is that the average grade in statistics of all senior high school grade 11 students in 2019 is 95.07 as the grade. Okay? So, meaning to say, for all senior high school grade 11 students. So, we are talking about the population of all senior high school grade 11 students in 2019, and their average grade is 95.07. Okay. Now, let's move on to learning and knowing what statistic is all about. Okay, in many books, statistic talks about the parameters, okay? Or not the parameters basically, but the information about the sample. A statistic, on the other hand, is a number that describes the sample, okay? The sample that you took from the population. It is a fixed number which we can calculate used in testing our hypothesis, and therefore, we know its value. For example, the sample mean, the sample variance, the sample standard deviation, and the sample proportion, etc. Okay? So, let me explain some example. Okay? Example could include the following. So, take a look at this. Very similar to the previous one, but it's different. Okay? A survey was taken, and the average number of children of 20 families in a small town is 7. Okay, take note did you notice the difference? A while ago, it's for the whole island, but this time we're talking only of 20 families taken from that small town. Okay, so you got the big difference. Let me see. Are you getting with the... Okay, are you with me still? Now, another example is the average grade in statistics of selected 40 Oxide senior high school grade 11 students in 2019 is 95.07. We're not talking of the whole senior high school population, but rather we're only talking of 40 students from my school, Oxide, Angeles City Science High School. Okay, you got the idea? Okay, so this is very important, no? That's why I want you to play a little mind game to identify if the given data is a parameter or a statistic. Okay, let's continue now. Now, let me discuss the most popular 4 statistical tests that you will want to be familiar with in doing a basic research. We will not be able to tackle all the tests because there are a lot, okay? It's one big mile of different research, okay? So instead, we'll just focus on the 4 most popular statistical tests. The correlation test, the 2-sample t-test, the paired t-test, and one-way ANOVA or analysis of variance, okay? So let me continue. First, we take a note as well that in hypothesis testing, we have the so-called one-tailed or two-tailed test. And for one-tailed, we can test if the new first parameter is greater than or less than the second parameter. That's why you have here, is it greater or is it less? And that is what we call the one-tailed. For the next one, the two-tailed, we are simply testing if the first parameter is not equal to the second parameter. Okay, so take note of that. Now, the first test, the correlation test, goes like this. Oops. Okay. The first is the correlation test. Let me go back. Here, the researcher is testing if there is a significant association between two given variables. This is very common among research. No? Example would be to test if there is a significant association between average daily calorie intake of students and their grades. Okay? And in using this test, if the normality assumption is met for the two variables, the Pearson R coefficient test can be used. Otherwise, Spearman's rank correlation is the suggested test. Okay? So here, we have an explanation for parametric test, meaning to say the normality assumption is, what do you call this? Met. Okay? You qualified to use the parametric because there is a normal distribution. If not, you can still test them using another test, which is Spearman's rank correlation. Now, how do we know that our distribution is normal? Let's take a look. Okay. Oh, wait. Before that, okay, here it is. The Pearson formula, which we will not discuss anymore, but I think for math majors, this is very common. They know this already. But for those who are not into mathematics much, okay, don't worry. Don't worry. Why do I say don't worry? Because you can always call on a statistician to assist you in doing the calculation. Okay? But the more important thing is you know what a correlation test is all about. Okay? And for the significance of correlation coefficient, this is what probably your statistician would use. No? Okay. So, and this is a very important one. The coefficient has a minimum value of -1 and a maximum value of +1. So anything beyond will be wrong already. If your statistician gives you a correlation of 1.25 or -2.8, okay, that's beyond already the limit, which is from -1 to +1. At least you know, right? So there you go. You can see on the screen the basic interpretation of the coefficients in terms of strength of association between the two variables. From very strong to, meaning to say the perfectly, no? Perfect, very strong to none at all, okay? And just to give you an idea, okay, if we apply the formula given the values of variables x and y, Excel can always provide us with the required sum, okay, and products, and therefore get the answer. So don't worry. If you don't have an SPSS, your Excel is very much of big help. So these are the values. But how do I calculate it without this calculation? Okay, using Excel, if you have your Excel, you can go to, okay, using Pearson R, okay, equals Pearson, and then the Excel will give you the necessary requirement, which is basically to get the X and the Y rows, no? You call it row? No, column. Rows and column. I got confused already. Okay. So using Excel, okay, you can use the more functions, statistical, and then go to correl. And that means correlation. Or another way is there you go, Pearson. Okay. You can type in Pearson, and then the Pearson function will show up. And again, it will require the X and Y values. So just a hint, no? So, but I will not be dealing with how to calculate it. Again, as I said, you have to focus on the type of test. Okay, the next one is the two-sample t-test. As the name implies, refers to testing the distribution of two distinct and independent groups, if they are similar or not. This is commonly used for experiments involving a control group versus an experimental group. Means measuring a similar variable like perhaps temperature, muscular strength, blood oxygen levels, or perhaps patience. Okay. Another example would be to compare the healing time of a group of patients who are given virgin coconut oil on top of a prescribed medicine compared to another group who are treated only with the same medicine. If the normality requirement is not met, a non-parametric test called Wilcoxon rank sum test is applied to the data. And how do we check if it's a normal distribution? Very simple. You can check the distribution by using a histogram, the most basic of the dependent variables per group, or using Shapiro-Wilk test. Okay, aside from Wilcoxon, of course, a Mann-Whitney U test can be applied if the normality requirement is not met. Okay, so there you go. The next test is a paired t-test. Okay, it's used when comparing two measurements taken from the same individuals or cases in a sample and testing if there is a significant change in their measurements after the application of some variable. Now, an example is comparing the scores of players in a sample before and after maybe drinking a certain energy drink. This is also called the before and after t-test. Okay? And if the normality requirement is not met, don't worry. There is always a substitute, and that is the Wilcoxon signed rank test. And as usual, you can, okay, where are we now? The paired t-test is used when comparing two measurements taken from same individuals. Did I say it already? The before and after t-test? Okay. And how do we check? We can check the distribution by using, again, the histogram of the differences or using Shapiro-Wilk test again. Okay. So another option is to use the Wilcoxon signed rank test for non-compliance. Okay. Now, let's go to the next one, the paired t-test. One can check the distribution by using a histogram of the differences or using Shapiro-Wilk test. A Wilcoxon signed, again, as I've said, this can be used, no? And if you're using SPSS, it's at the bottom row of the t-test. Okay. And let's take a look at the last one. The one-way ANOVA. This is quite complicated for many, but if you are familiar with the applications in statistics, this is just a simple task. There are times when the researcher would like to compare the means or more than two variables. Okay, say variable X, Y, and Z. You have three variables, let's say, or more. Perhaps one can think of doing a t-test on X and Y. Okay, then another t-test on Y and Z, and another t-test for X and Z. However, for statistical reasons, it is considered illegal, okay, to use t-tests over and over again on different groups from a single experiment. So we don't do that. If there are three groups, then we have a test to do to handle that statistical analysis, okay? Thus comes the one-way ANOVA, which is used to compare means between three or more distinct and independent groups. An example is comparing the efficacy of three medicines, let's say, on three groups. So we have ABC and medicines 1, 2, 3. Okay, we are going to compare them. Again, if the normality requirement for residuals, the differences, is not met, the Kruskal-Wallis test or Welch test is applied. And to check for normality, a histogram once more. See? You see how important the histogram is? Or a QQ plot of residuals, or a Shapiro-Wilk test can do the magic. Okay? So there you go. Let's talk about the four different tests. Okay? So don't worry about if the assumptions is not met. We have the Kruskal-Wallis test. So there you go. Another example is measuring your feet size. Okay, this I saw in one of the experiments. Okay, each morning, noon, and evening for the next 30 days. Wow! And record the results and test if the sizes tend to differ for the three measuring times. Meaning to say, if they significantly differ, wow! That means by time, one can assume that indeed our feet change its size during the day. And isn't that wonderful or frightening? It all depends. Okay. So there you go. Let's have another. Well, there you go, ladies and gentlemen. I have about 1 hour. For 1 hour, I have given. I hope I have given you enough knowledge to learn more about the significance of statistics in coming out with informed decision regarding assumptions on our population. So, with that, I hope you can enjoy doing your research. Okay? And as I've said a while ago, if you're afraid of doing the research because of the statistical part of it, don't worry. There are a lot of statisticians around who are ready to assist you. You can always contact me. Just an advertisement. So let us recap. Okay? So let's see. You can answer on our chat box to test if having games in between class will produce a different result between sections A and B. The researcher applied the game's activity in section B while not in section A. So assume normality. What do you think is the answer? What kind of test will be used? Can I see from the chat box? Okay. If the teacher will give games in between classes, will it produce a different result between two sections the teacher chooses? Okay. So meaning to say, the teacher will apply games on one section or one class, but not on the other section. Okay, what kind of test would you use? Of course, let's see. If your answer is two sample t-test, you are correct. Okay, since the two sections are distinct and independent groups, comparing their average grades can result into a statistically similar or statistically different. Hence, a two-sample t-test can be used. Let's go now to the next one. To test if giving medicine X will improve the breathing of patients with COVID. The researcher took breathing measurements before giving the medicine X, okay? And after. Before and after giving the medicine, okay? And assume that paired differences is not normally distributed. Okay. I think there's some typo error here. The researcher took breathing measurements before and after giving the medicine X. Okay, that's what it means, no? Assume that paired differences is not normally distributed. Well, what do we do? Of course, let's take a look at the answer. Since this is a before and after type of test, a paired t-test can be used. However, it did not satisfy the normality requirement, so the Wilcoxon sign rank test will be used. There is always a way out, okay? Let's go now to the third question. The researchers are looking at three factors that can contribute to COVID infections of residents of a certain area. What test shall be used to assess if the factors, okay, are equally potent as the others? Okay, assuming all variables are normal. Okay, let's go back now to having a normal distribution. So what do you think? Of course, you got it already. There's only one, and that is since there are more than two factors to compare, one-way ANOVA is likely to be used to know if there is a significant similarity in the degree of effect among the three factors. But mind you, ANOVA, you can have a two-way ANOVA, okay? You can also have ANOVA, which is an analysis of covariance, okay? So you can learn that later on, okay? But just to give you an idea. Okay, and for the last one, you wish to know if there is a significant association, okay, between the number of times one washes hands to spreading of viruses among health workers or healthcare workers in a small clinic. What is the best test to use if the variables are not normally distributed? Again, we have this not normally distributed. Okay, let's take a look. If normally a correlation test using Pearson R can be used. However, due to non-normality of data, the Spearman's rank test will be used. Okay, so I hope you are able to understood clearly the four significant statistical tests, the most popular, I mean. Okay? And you can always do now your research without much worry on the statistical part. Okay? Oh, by the way, in case you wish to check on my other educational videos, you can visit my YouTube channel, Sermon, and feel free to subscribe as well. I want to see you there. Okay? Thank you once again to IGP, the International Global Professionals, for inviting me to share my knowledge in statistics for this webinar. It has been a pleasure being a part of this endeavor. And thanks also again to our Regional Math Supervisor, Dr. Nestor Nuesca, our School Division Superintendent, Dr. Irene P. Tamayo, our District Supervisor, Madam Esperanza Malang, our School Principal, Madam Casarina L. David, and our Senior High School Head and School Assistant Principal, Madam Lutgarda C. De Jesus, and to our sponsor, to our MC, thank you very much for this opportunity. To God be all the glory. Thank you and good night.